Yeah, welcome back. It's been brought to my attention that I haven't explained how all this works enough for people to understand where I'm getting these numbers from when I'm manually coding for these parts. Uh, Over here, I got a schematic of a 2-inch wide, 2-inch tall square with a 1-inch circle right dead center of it. Now, for parts like this, and parts in general, I'll set my WPC right here in the center. And especially for a part like this would be your y-axis, this would be your x-axis. From center to this side, 1 inch. From center to this side, 1 inch. Center to this side is 1 inch. And center to this side is 1 inch. And the same thing when I go to swing the arch. Center to the edge of this arc, 1/2 inch, all the way around. And it keeps math simple. That's all this is you're going to pick a starting point and you have to tell the machine where you want the exact center of that spindle to travel along. This little yellow icon over here, this is UGG's way of showing you where the WPC is. I know a lot of you guys like to do it on a corner or whatever, but like I said, for this and for me, how I prefer to do it, would be off the dead center of the part. So when you start coding, you come up here and click save on it. It's going to base every dimension we put in here is going to be based off this point. When you're on the right side for X, that's plus. When you're on the back side for Y, that's plus. When the Y is closer to you is minus. And when X is to the left is minus. Meaning, let's say I want to move my spindle, the dead center of the spindle. We're not worried about tool offsets, nothing. We just want to move the dead center of the spindle right to this wall. That'd simply be a G1, which is a feed move, X minus 1, because it's on this side. This is negative. I'll give it a feed rate. Now you can see that this thing is moved over 1 inch. This is my WPC, and it's moved over 1 inch. Now that my spindle's sitting right here, the X was told to travel directly to the center line of this point. If I wanted to put it right here on this top left corner, all I have to do from here is tell it fly 1 inch. And that's going to be positive because this is positive, this is negative. And that's because my WPC, my center line, my X0, Y0, Z0 is right here. So if I tell it Y 1 inch, 1 inch, not 0.1 inch, have it. Now you can see it's showing the movements. I first I first told it to come straight over on the x-axis, 1 inch. Then I told it to come over on the y-axis, 1 inch. So right now, the dead center of that spindle is sitting directly on this corner. If I wanted to go to this exact corner, I don't have to do any math here. Only thing I need to worry about is the math from this center line here on the y-axis, because the x-axis is already in this position. I don't have to touch it. All I have to do is tell y-axis where I need it to go. That's 2 inches, but it's not going to be 2 inches in the G-code because 1 inch will be from here to the center line, the WPC. Then from here, it'll be negative 1 inch. So if I put G1, Y, negative 1, save it. Now this just updated. Here's my X line coming out. We first told it to go +1, and now we told it to go -1. And again, why that moved 2 inches, even though there's just a 1 in there, is it was 1 inch from 0. Every movement is going to be based off this WPC. So when we told it -1, that took it from here and put it 1 inch below its center line. And since x was already over here, -1, it's riding along this line right here. And it's the same thing. If we wanted to go from this corner to this corner, we're again crossing that center line. This will be on the x-axis. If we took -1 to 0, that would put us dead center. And then if we told, if we just told it +1, then it would go from negative to 0, 0 to +1. Really should leave a gap between the G1 and the letters right here. So now we just updated. We went from -1 to +1, or 2 inches. Now we want to do the same thing on Y to follow this line up 2 inches. This is our Y center line right here. Right now it's -1. So if we tell it +1, it's going to go from -1, 0, +1. Now we're all the way up here. And if I tell it to go, x -1, it's going to go x +1, x 0, x -1. It's going to make that 2 inch travel back across. And we just drew that box basically right here by those simple codes. And that's all because the WPC, since we're doing this, manually, we're going to put WPC in the easiest place. So then when you go to actually carve this, you would have to find the center of your part, which is pretty easy. You can just draw a pencil line corner to corner, eyeball it with a V-bit or something. If you got probes, I normally use edge finders, but we're kind of getting off topic here. Now the next thing to understand is the Z. See, right now I got Z at 1/4 inch, 0.25. And just like you got positives and negatives for X and Y axis, you have positives and negatives for the Z axis. Z0 would be sitting directly on this part as you set it. If I drew an X across this, it's just a blank piece of wood. I brought my tool over here, eyeballed at the center, lowered my Z to, the piece of paper, or you can use probe, whatever. Say a piece of paper just snags, that's where I set my Z, that's 0. Any positive number is going to raise it up higher. Like if I come down here, I don't know how well that illustration is going to do it. We'll put a G1, Z, yeah, I'll have Z come up 2 inches. Now you see this nice line of Z coming way up here to the top. That's because I told my Z to come up. We're 2 inches above the part. If I tell Z to go down, what is our part, 130,000? Well, that's not going to do it. To go -130, it will now go all the way down to the bottom of our part. I'll open it as this. Now you see that blue line just protruded straight to this top plane, because this plane right here would be the very top of the part where we set our WPC. That's Z0. It just shot all the way down the part. And I don't recommend doing that, obviously, but just for an example. And now you understand that part of it, hopefully. Uh, Z0 is the very top of the part where you taught the tool when you're touching off top of the tool. Now, different places you teach, different places these are, but I'm going to try and keep this as simple as possible. And then all movements will be based off that center line because that's where I put it, or that's where I'm coding for. If you put it over here, then all movements would be based off this point right here, or up here, or over here, or over here. Wherever you place that WPC, every movement is based solely off that. So you're up here and you thought, well, I need to move 2 inches down, but you didn't put 2 inches down, you put -1 because we're based off this position right here. And then be the same for my arcs over here. I'd have to get in position first, but it's going to be a 1/2 inch. Half of 1 inch, half of 1 inch, half of 1 inch is 1/2 inch. Almost a tongue twister. And just do the 4 arcs going around and spiral it down and everything like I showed in other videos. And to offset, which would be the next biggest thing. Once you grasp that, what you got to understand is this is the very center of the spindle, or the very center of your tool. So if I had, I don't have one listed up here, say 1/8 inch tool. If I had an 1/8 inch tool, a 1/16 of that tool is on this side, and a 1/16 of that tool is on this side. If I was up here, a 1/16 be on this side, and a 1/16 be on that side, because half of 1/8 inch is 1/16. That's the very center of that tool. So if I wanted to come over here and actually start cutting this, I have to take into account that 1/16 of that tool. Otherwise, my part's going to be 1/16 short here, 1/16 short here for an 1/8 inch small altogether. Sixteenth is 0.0625. You can see now my box changed from 2 inch to 2 1/8 overall, 2 1/8 overall, because each side got added a 1/16, and that's accounting for the width of that end mill. I'm using an 1/8 inch. If it was if it was a 1/4 inch, you'd have to take an 1/8 inch extra per side. It's all based on the width of that insert. And then this is assuming that the tool is exactly an 1/8 inch, but I think I touched base on that already. They hardly ever are exact the size that they're rated for. But hopefully that clears up some of the misunderstandings. Guys had a hard time figuring this out there in group. And feel free to ask me any questions you want, whether it's on a YouTube video or in the group or whatever. And I'll try and sit down and explain it better. But just remember, all coordinates, that's all this is, are coordinates. And then you have different things. You got G1 feed, GO, which is rapid, which you'd never do inside the part. Even if you're already cut away, always feed it out of the part before you wrap it. That'll save you a wreck later. And then your arc moves and whatnot. But just always remember that all things are based off this. Let's see. Let me get position here real quick. Let's do G1 X. I have no idea where my Y is right now. Okay, that should put that cutter right here. Center of my spindle will be on that bottom lower corner. Now, if I wanted to draw a straight line 45 degrees from this corner to that corner, then all I have to do is tell it this X and this Y from this center line. Even though it's going to travel from here all the way over to here, The only thing I got to tell it is this ending point, because this will be a starting point right here, the last movement. And then like just a regular G1, it's going to feed from this last movement to the next coordinates you put in here. So now if I told it to go to that top right corner, you'll now see we got a 45-degree line from this corner all the way up to this corner. This angle is horrible. Side to the visualizer. You can see it actually cuts right through that WPC, dead center. And that's because everything is based off this position. All your math, your coordinates is all off this position. Not where you're at, but this position. So you can change, well, I'm not going to get into that, but just keep that in mind, is everything's based solely off of your WPC. And this is why he put it in center for such an easy part as this is. I don't know what you even machine that for, but it's super easy to just, because once you know one dimension, boom, you already got them all. Same thing with this arc. You can come over here, do your compensation for it, arc, and just swing it right around, right off the center. Where if my WPC was sitting right here, that would be 1 inch over, 1 inch up. And then I'd have to base all of these off of that, which is going to be positive and negative, swinging it around arc. I got other videos on arcs already. But this just keeps everything really simple. Hopefully that clears up the confusion with calculating the math for here. If any other questions are about this, let me know, and I'll see if I can touch bases on them better.